Hi Year 11s, it's Mr. Lim again, and here's another video on limiting reagents to follow our stoichiometry video. Alright, so when two reacting substances together, they may not be in perfect stoichiometric ratio amounts, which means that if it's a 2-to-1 ratio, you might have 2-to-3 or 2-to-4, and so therefore it's not going to be a perfect ratio. What happens when that happens? That means that one substance will run out while there is some left over of the other. Okay, that happens a lot. That happens almost all the time because you never have anything in perfect stoichiometric ratios. The one that will run out is called the limiting reagent, and the one that is left over is called the excess reagent. To work out which one will run out, which is the limiting reagent, we will compare how much of one reactant we have to how much we need to react of the other reactant. Okay, so let's just say, take into account we have A plus B makes C plus D. Okay, so we compare how much of one reactant we have, that might be A, to how much we need to react with the other reactant. Okay, so this part would be the number of moles of A, because this is the number of moles of A, that we need to react with B. Alright, and how do we work this out? This one we work out via stoichiometry. Okay, so let's go to have a look at it. Okay, so to do this we need to solve for the number of moles of each reactant. We need to get number of moles of A and number of moles of B. Alright, once we've solved for number of moles of A and B, we can solve for the number of moles of one of the reactants required from the other moles of the reactants. So this would be the number of moles of A needed. It would be equal to the number of moles of B times the coefficient of A over the coefficient of B. Right. Compare the number of moles with the number of moles that you have of the reactant. Okay, so we're going to call this one the initial amount. Right. So we are comparing the number of moles of A we have initially compared to the number of moles of A that we need from B. Okay, if need is greater than A, let's have a think about what that means. If we need more than we started with, that means A is going to run out. Okay, if required is more than you have, so in other words, need is more than you start off, then it is the limiting reagent. That's A. Right? If required is greater than have, so that's the other way around. Right? If you started off with more than you need, then the other substance is the limiting reagent. And then you state which one is the limiting reagent. Okay, so let's have a look. For the following equation, we balance their equation and then answer the questions that follow. Okay, so the first one here, balance this equation. It's going to be 2, 13, 8, and 10. 10. Okay, so let's work this out. First of all, we need to work out the number of moles of both reactants. Okay, so number of moles of C4H10 will be equal to 12 over 58.01.12. Okay, which will equal 0.206 mole. We're going to save that in our calculators as A, so we're going to write it down as A. Okay, so that's the number of moles of our first reactant. Now we're going to work out the number of moles of our second reactant, the number of moles of O2. That's going to be equal to, what's our mass? 9 over 32, which happens to be 0.281 mole. And we're going to save that in our calculators as B. All right. Once then we can work out the number of moles of each reactant that we start with. We're going to call these I for initial, right? Or H for have, or you can write down have, or whatever you want to call it, right? We have to work out the number of moles of one of them that we're needing. So we're going to do C4H10. Now, you can use the other reactant, so you could do this with O2. Doesn't make a difference as long as you know how to read the next part later on. So let's have a look at the next part of this equation. Number of moles of O2 will be equal to, that's the I, so therefore that is going to be, what's the molar ratio? So it's the coefficient of the unknown, 2 over the coefficient of the known, 13, right, which will be equal to 0.04 mole. Right, so which one of these two, this one or this one, is larger? Right, and we're going to save this one as C. Which one is larger? I is greater than, or initial is greater than we need. And you should really write it as N bracket C4H10 is greater than number of moles of C4H10 that we need. We just need that there. All right. Okay. So we have more than we need. If we have more than we need, we are not going to run out of C4H10. We are going to run out instead of O2 is the limiting reagent, because we're going to run out of the O2. Okay. That's how you do that equation. So number one, you work out the number of moles of both reactants. Then you work out one that you need. Then you write down, okay, I'm comparing these two, that one is greater than that one, and then you make a statement about the limiting reagent after you balance the equation. Okay, so that's that one. Right, there's another question here. You can have a go at it later on. Right, all I can tell you that the answer is at the end that the O2 is the limiting reagent. Okay, so O2 is the limiting reagent. All right, so let's have another try at this one here. Okay, so here we have the balanced equation 2, 3, 6, 0, or 1. Okay, so we have the number of moles of H3PO4 initial. All right, it's going to be 120 over 97.994, which would be equal to 1.22 mole. Okay, then we have the number of moles of BA bracket OH bracket 2, which will be equal to what's that, 90 over 171.316, which will be equal to 0.525 mole. Right, so there we have we've worked out the number of moles of initial of both of our reactants. Now we have to work out the number of moles needed of one of them. So we're going to work with the number of moles of H3PO4, and remember, you can use the other one, just have to read the inequality statement correctly. So this is the number of moles of that one that we need, right? That's going to be equal to the number of moles of BaOH2, that's the other reactant, times the molar ratio. What's that going to be? The coefficient of our unknown, which is 2, over the coefficient of our known, 3, which will be equal to 0.35 mole. Okay, so 0.35 mole. Okay, so we've got that. We now have to compare the number of moles of H3PO4 needed compared to the number of moles of H3PO4 that we initially had. Right, so which one is larger out of these two? It's the amount that we initially had. Okay, if the amount that we initially had is greater than the amount that we need, therefore the BA bracket OH bracket 2 is the limiting reagent. It's the other substance. We initially have more than we need, so therefore the other substance is the limiting reagent. All right. There's another question. You have to think about how best to answer this, but I'll give you the answer. It's more than 25.55 grams. Okay, and you have to think about why you need that more than. Okay, right, so to determine the number of moles of excess reagent, remember we ran out of one before we ran out of the other, so therefore there's going to be one in excess. You subtract how much was used from how much was initially there. So to do this, you have to do all the steps of limiting reagent. Then you have to use the limiting reagent to work out how much of the excess reagent was used up. Okay, how much of the excess reagent was used up. So again, if we use our A plus B makes C plus D example. Okay, let's just say that B is the limiting reagent. That means A is in excess. Okay, if A is in excess, we have to work out how much of the excess reagent was used up. What's using it up? B. So how much of A was used by B. Okay, so then we subtract that amount that was used from the amount that you started with. So the excess will be equal to the initial amount, subtract the amount that we use. Okay, so let's have a go at that. Let's have a look. Okay, here it is. So there's one more question as well, but we'll do that later. Okay, balance this equation 10, 10, 2, and 15. Okay, so we're going to work out limiting reagent all over again. So let's do it. Number of moles of C5H10 will be equal to 13 over 70.13, which is equal to 0.185 mole, which we'll call A. Okay. Then we work out the number of moles of O2, which will be equal to 15 over 32, which will be equal to 0.469 mole, which we'll call B. Okay. Then we can work out the number of moles of C5H10 needed. Remember, these are initial. From the number of moles of O2 initial times the stoichiometric ratio, which happens to be 2 on 15, which will equal 0.0625 mole. And we'll call that C. Okay, we're going to compare the number of moles of C5H10 initial and the number of moles of C5H10 needed, and which one's greater? The amount that is initially there. Right, so since the amount that is initially there is greater, that means that the O2 is the limiting reagent. Okay, so now we know what the O2 is limiting reagent, so now we know that the one in excess is the C5H10 is in excess. Okay, so if we know that that one is in excess, let's work out how much there is in excess. We have to work out the number of moles of C5H10 that was used by the O2, the limiting reagent. Luckily enough, we already know what that is, okay? It's this number here, okay? So it's C, because this number is the amount that is used. That's the amount that is used by all the oxygen, because we've already worked that out. That's how much we needed. Okay. If you chose to work out oxygen, well, you wouldn't have this number. You'd have to work it out by the stoichiometric ratio. Okay. But we've already done it. So let's move on. So we have to work out the number of moles of C5H10, which is excess, which will be equal to the number of moles of C5H10 initial, subtract the number of moles of C5H10 used. Okay, how much we started off with, how much was used, will give us how much is in excess, which happens to be, this is why we save numbers, A take away C. And if it's A take away C, it's 0.123 mole, and we'll save that as D. Then we can work out the mass of C5H10, which will be equal to N times M, which will be equal to D times 70.13, which gives us 8.6 grams. Okay, so that's the way that we can work out the mass of the excess reagent. All right, the other one is very similar to it, but I can tell you that the answer, the mass of the excess reagent, is 2.26 grams. And what is the limiting reagent? It is, again, the O2 is the limiting reagent for the second question. Okay, you go give it a go, and if you can't do it, you go ask me later on. Okay, here is another one. Let's go practice this one. there's another question for you to practice as well. Let's do this all over again. Okay, so we can work out the number of moles of HNO3. And I'm going to do it in my head. It's 0.857 mole. That's A. Okay. We can work out the number of moles, and that's the initial one, number of moles of Al2CO3, which is equal to 0.256. That's B. Okay. You should also know that this balanced is 6, 3, 3, and 2. Okay. So we can work out the number of moles of HNO3 needed, which will be equal to 1.54 moles, which we'll call C. Okay, and we can then work out that which one's larger, the needed or the initial. The number of moles of HNO3 needed compared to the number of moles of HNO3 initial, which one's larger than needed, right? So then we know that the HNO3 is the limiting reagent. Okay, so now we need to work out how much is the excess used. Okay, so that's the excess is the Al2CO3. So to work out the number of moles of Al2CO3 that is used, the number of moles of Al2 bracket CO3 bracket 3 used will be equal to the number of moles of HNO3 times, when I say 1.6, okay, which will be equal to 0.143 moles, which will save as D, right? So remember, we have to do this step here, because we didn't do it over here. But sometimes you will do it over there, and so therefore you can just use that value, which is kind of useful. All right, now that we've got the amount that is used, we can work out how much Al2CO3 is in excess based on how much we started with, Al2CO3 initial, subtract the number of moles of Al2 bracket CO3 bracket 3 used, which happen to be B, take away D, that's why we love saving numbers, which happens to be 0.114 moles. And if that's that, then we can work out the mass of it, of the Al2CO3 excess, which will be that value times 233.99, which is 26.6 grams. Okay. The next question there, I can tell you that it's not HNO3 that's the limiting reagent, it is the Al2CO3 is the limiting reagent, and the mass at the end is 40.89 grams. Give it a go yourself. If you don't get these numbers, you can come and ask me. Okay. Now finally, with limiting reagent, the number of moles of a product can only be solved by using the number of moles of the limiting reagent. And that should make sense, because if it's the one that you run out of, when you run out of that, you're going to stop making products. So therefore, all of the excess stuff will not make any more products. Okay. So if you use the number of moles of excess reagent, you have a value that is too high. Okay. So because you'll be like, oh, I'll work out how many products I have from the excess reagent, you'll be not taking into account that the limiting reagent has run out, and then you'll be saying that, oh, I'm going to use all of the other one, which is not good. Right. So here's an example. Here is an equation which we'll just balance quickly. 6, 2, 2, and 3. Okay. If 13 grams of hydrochloric acid is added to 6.5 grams of aluminium, determine the limiting reagent. All right. The limiting reagent is the HCl. You can go work that out yourself. The mass of the excess reagent is 2.65 grams. Right. And the mass of the aluminium chloride. Okay. So what we need to consider is the number of moles of aluminium chloride will be equal to the number of moles of HCl, which is the limiting reagent, times 2 on 6, right? That happens to be 0.357 times 2 on 6, which is equal to 0.119 mole, right? Then you times that by its molar mass to get your mass of that. And the mass there is 15.85 grams. Okay, so the idea is that you're using the limiting reagent as the thing that you're working out your products from, and that's super important. Okay, all right, that's it. See how you go, answer the questions, answer the worksheets, and then if you have any problems, let me know.